All right. All right. Hello, everyone. Welcome to our day 2 of our Python course, phase 1, day 2. Today, we're going to be starting off by going over assignment 1 homework, how to code it, and then we'll be moving on to our next topic for Python, which is data structures. So I'll be going over the homework for today, and then I'll transition it over to Scott to take over for data structure stuff. So let's go ahead and first take a look at how the assignment works. Okay, cool. So the assignment asked us to create basically a number guessing game in Python. So the first thing that we want to do is have our computer randomly generate a number. So the way we can do that is by first using the import keyword to import a random the random library. So we'll say import random. And if you don't want to keep writing random over and over again, you can say import random as rand. And that'll make it so you can use this keyword rand instead of random to get the files. All right, so now the next thing that we want to do is be able to have our computer randomly generate a number and store that into a variable. So let's go ahead and create a variable called number, and we will assign it a random number from the random library. The way we do that is we first say rand dot, and then we use one of the random function libraries, or the random functions from the random library. In this case, I'm going to use rand int. That let us randomly generate an integer. And in order to randomly generate an integer, we're going to have to provide a range. So the task, our assignment told us that we wanted to randomly generate a number between 1 and 100. So we'll just do 1, 100, and that'll randomly generate a number including those two endpoints. All right, now that we have a random number, we'll be able to kind of create a game loop. So the way we do that is we want to create a while loop that runs forever, because we don't know how many times the user is going to want to try and guess and find out what the number is. So we'll use a while true loop to make sure we loop over and over again and use the keyword break once they guess the right number. So now we're going to need to get an input from our user. So we'll create a variable called user input. We'll assign that an input that we get from using the input function. So we do input, and then we'll have a prompt as a number between 1 and 100. Now, input stores stuff as strings, so we want to turn that into an integer so we can compare that against our randomly generated number. So the way we do that is by using integer casting. So we'll put all of this input inside of the int function. So the input will get something as a string, and the int function will take that string and convert it into a number, and then we store that into user input. Now we can use our conditional blocks to basically determine whether or not their answer was correct. The first thing we want to do is make sure that they chose a valid number. So if their number was less than 1 or greater than 100, that's an invalid answer choice. We'll have an if statement that will check for that. So we'll check if user input is less than 1, or, so we use the keyword or when we want to check for two different things. And we'll say user input is greater than 100. That's true. Then we want to print out that they did an invalid choice, and then we move on with the next thing that we're going to check, which is, so we use an elif for our next check, and we're going to check if the user input is equivalent to our number. And if that's the case, that means they basically got the right answer, and we can break out our loop. So to do that, we'll say user input is equivalent to, so we use the double equal sign to check if two things are equal to each other. And we're going to check if it's equivalent to the variable number. If that's true, we can print out good job. Job. Oh, whoops. Job. Yes, it right. Something like that. And we can break out of the loop. Now we'll have two last conditional statements to check whether they guess too high or too low. So for the one for too high, we can say if user input is greater than number, then we can just print out that that you guessed too high. Guessed too high. And we can have an else statement for the last one because there's nothing else we want to check after that. So if all three of these were incorrect, I mean, the last thing that could happen is the user guessed a number that was too low. So we'll just print out guessed too low. And that should be all we need for the program to work. We can go ahead and test that out by running it. Guess a number between 1 and 100. So I'll try it with 50. So I guess too low. So it must be greater than 50. So I'll try 75. I guess too high. So it's now between 50 and 75. So I'll try 65. I guess too low. So it's between 65 and 50. So let's go ahead and try 55. Guess too low. So between 50 and 55. So let's try 53. Guess too low. Let's try 51. Guess too low. Wait a minute. Wait, let's see. If we guess, wait, I think I might have messed up with my logic there for a second. Guess too high on 75. Guess too low on 65. Sorry, it should have been between 65 and 75. Yeah. Wait, is that right, Scott? Did I mess up somewhere logically?
No, your new logic is correct.
Okay.
Yeah, Brian, you're exactly correct. And actually, you can get it within, I think, 7. Is that right, Sahas?
Yeah, you should be able to get in 7. I'm just being dumb and.
Yeah. So that's basically the entire homework assignment. We will be looking through those submissions by this weekend. So you'll probably get replies by Sunday night. Is that right, Sahas?
Yeah.
Yeah. So be ready for that, and then we'll be able to give you a little hint or give pointers on how you can improve your code next time. And yeah, I think without further ado, if we don't have any questions, we'll give about 10 seconds for that. But if we don't have any, we can move on to today's topic. Alrighty. So today's topic is data structures. So last week we went over variables. So if you were to think of variables as little boxes for your items and what you want to store, you can think of data structures as different kinds of shelves or cabinets to store those boxes. So if you think about having multiple variables that you want to keep in line. So for example, if you had like 5 dogs and you wanted to keep track of all of their names, you don't need to make 5 different variables for each of their names, like dog 1, dog 2. You can just have a list of dog names, and then you can just store them all. And that's actually the first thing we're going to be looking over. So we're going to go over lists today first. So for those of you who've used C++ before, they're a little bit similar to arrays, but they are a little bit more powerful and a lot easier to use. So the first thing is to instantiate or to create the variable. You can either create a list that already has items, or you can kind of make an empty list. Basically, create the cabinet with all the boxes in them, or you can just make it empty. So we're gonna make it empty first. So as Sahas is doing, lists are kind of encapsulated by square brackets. So that's next to your P key without pressing space. And at this point, this is basically saying, okay, I have a cabinet that that can hold different things, and there's nothing in it right now. And one really neat thing that you can do with lists, which we'll be doing a lot just for educational purposes, is that you can print them out. And this happens completely natively. You don't have to do anything special. So if we just do print list 1, it'll actually just print it out. All right, and as you can see, there's an empty list. Now, the way that you can put items in a list is with basically you just put commas between each of the items. So if we go back to the first list, we can just do 1, 2, 3, 4, and 5. And right here, you notice that we have commas between them. So this is just like to make sure that Python knows, okay, what are the boundaries between these items, and basically separating them. And one thing to note is that while usually you do want it to have all of the same data type, so basically you don't generally you want to have all integers or all strings or stuff like that. You could technically have it with different data types. So if you stored a string with an integer, for example, that's completely valid. Generally not not super recommended, but it does work. So we go ahead and print list 1 right now. It'll actually print out each of these things. And one cool thing with lists is that you can actually duplicate them. So basically, if you want to type out, if you want to print out a list that's basically 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, you can just you can tell Python to multiply it the same way that you do with math. So list 1 equals the list times 3, and it'll print out 1, 2, 3, 4, 5 3 times. And if you notice, it's in the exact same order, and it's actually all in the same list. So it doesn't make separate lists. It basically just duplicates the what are called elements inside. So elements are basically the little boxes inside of the list. And one cool thing with lists is that you can actually store lists. So if you think about having a huge room that has boxes with boxes inside of them, kind of like Russian nesting dolls, you can actually do lists of lists. And those of you who are kind of more used to computer science, this is basically how you can do two-dimensional lists. So basically, it would be the first row would be 1, 2, 3. The second row would be 4, 5, 6, and the third row would be 7, 8, 9. And the nice thing about Python is if you're between the brackets, you can actually type on new lines and it'll be completely fine. So that's kind of like what the grid would look like in the computer. And you can actually just think of it like that. Before moving on, any questions on that? Okay, cool. So one thing that's kind of important is, well, accessing the data inside of that list. So you have a list, and you can print the whole thing out. But what if I just wanted the first one, for example? It would basically be kind of like saying what place would you want to print it in. So for those of you who aren't computer science or who have not coded before, we usually start counting from 0. So the first item in a list would actually be 0. So the 1 would be at what's called the index or place 0. 2 would be at index 1, etc. And the way that we can do what's called indexing lists or getting the items within them is by using the same square brackets that we use to create it. And once we get rid of that little demonstration, we can actually print out. So if we wanted to print out the first item of the list, you would print out list and then the square brackets and then 0, right? And that's really useful if you just have a lot of stuff and you need to get one piece of that list. So if you had, if you wanted with the dog example earlier, if you wanted the name of just one of your dogs, you could just print out the first one. And you can actually do this in a for loop. So this is really something that's really useful. So last week we went over the range function to iterate through numbers, but now we can actually directly iterate through list elements. So basically, instead of having to keep track of where the items are, we can just say for every item in the list. And same thing with last week, we use I, j, and k as kind of our really common variable names within the for loops, right? And always remember to put that colon there at the end. And what this is going to do is whatever code is inside of that for loop, it's going to happen for every element in our list. So for example, if we printed out just I, so we just print I. So I, each time the for loop goes back to itself, it would be 1, 2, 3, 4, 5. So let's go ahead and print that. Yeah, and we do have that times 3, so we take that out, it'll be a little bit easier to see. Yeah, and yeah, and one cool thing is you can actually do math on I, and it won't change the list. So if we do I times 3, then it'll multiply each one times 3. But if we put another print statement outside and we just print out the original list, it's actually going to come out not having changed at all. Right. So this is really useful if you need to do calculations on list elements, but you need to preserve the data inside of the list. Any questions on that? Okay, so the next thing we're going to go over is it's similar to indexing lists. So right now we know that we can put in a number into square brackets to get a single item of a list. But what if we wanted to get a portion of the list, what's called slicing? So if we had 10 dogs, how would you get the first 5, for example? So so yes, we're going to have a sublist to be equal. Let's say we wanted to get the numbers 2, 3, and 4. Right, 2, 3, and 4. So what indices would those be? It would be, well, 2 is in the second location, right? So 2 is in the second location. That means if we're counting from 0, it'd be 0 and 1, right? So you'd start at 1 and you want it to end at 4, which is the third position. Okay. Now so similar with the range function from last week, what our numbers that we're going to use is actually going to include the first one and exclude the second one. So before we go into any more explanation, we're just going to do a quick demonstration. So if we wanted to print out 2, 3, and 4, we would do list 1 and then 1:4. Yeah, so that's basically saying from position 1 to position 4, and it always excludes that last one. So we print out sublist right there. It's going to have 2, 3, and 4. And know how that sublist is a list itself. So it basically made it made its own variable. Okay, and so one cool thing with Python is that you can actually leave out some of those numbers if you don't need them. So for example, if I just wanted to print from the beginning up until a certain number, I could just take out that first number. So if I just do :4, it'll print out everything up until that 4th location. Right. So notice how this time it includes the 1 because we're starting at the very beginning. Now, conversely, we could print out everything until the end, right? So if we started at 1 and we went to the end, it would print out 2, 3, 4, and 5. Right. Any questions on this part? I know this part is kind of weird, especially if you're not used to Python. Okay. So obviously, sometimes you won't be able to have the same, or you won't have the list that you want to work with at the very beginning. Basically, if this only works with sequential elements, you can't skip indices or anything. Oh, yes, so that's a great question. So you can actually skip indices. This is a little bit more advanced, but I think it's worth showing. So basically, if you, basically, the first and the second numbers will be your beginning and ending location. And then you can do another colon and do what's called your step size. When saying slice out, that means, yes. So when we say slice, it's kind of like taking a slice of cake. So when you slice a cake, you take that chunk that you cut out instead of taking the rest of the cake, right? So the exact same thing happens in Python, where when you take a slice, it keeps that keeps between those two bounds, and you just leave the rest of it. Yeah, that's a good question. And regarding Brian's question, this is kind of how you do step sizes. And in this case, you just skip every other. This isn't super common in terms of application, but it is good to know. Yeah, and no problem. And so right now we know how to read lists and read items from lists, right? But sometimes we do need to change them or add to them. So the first thing we're going to do is learn how to change list elements. So let's say I wanted to change, the second or maybe the third element to something wacky. For now, let's just change the third element to the string hello. So again, if we want to do the third element, we minus it by 1. So we do list at 2, right? And then we just do an equal, just like a regular variable. And then we put whatever we want. So we can just put in a string. We can just say hello. Yeah, and if we print out the entire list, we can see that the list elements have all changed. Right, so we completely lost that 3 and we replaced it with that hello. Okay, so that's changing things that are already there, or basically replacing existing elements. Now, if we wanted to add an element, if we're going with the same example with your dogs, if you just got a new puppy and you need to keep track of their name for some reason, there is something called appending. So as the name implies, when you use the append function, you can actually append a new element to a list. So right here, we're doing list1.append. So that dot is called the dot operator. That means whatever function you put after that dot, it will pertain to the variable on the left. So that's basically saying, okay, from when we're dealing with list1, I want to use list1's append function, which is built into lists. And inside of those parentheses, we can put whatever we want to add. So if we wanted to add, let's say, what's a dog name? Russell, I guess. Then you could, yeah, that's a good spelling. or Buddy, that works too. And then once we have that, so at that point, we have 1, 2, hello, 4, 5, and Buddy. So let's print that out and just to show everyone. All right, so the first 5 elements of the list have not been changed at all. Append only adds a new element to the list, and as you can see on the bottom, it added the name of your new puppy, right? And this is really useful, especially if you need to add things a lot. If you're doing a lot of calculations and you're keeping track of the accuracy of certain measurements, and you're doing it for multiple pieces of data, you want to be able to add on to that every single time. And just as there is adding something, you can actually remove something from a list. Oh, actually, sorry. There's one more thing with adding to a list that I forgot. So there's actually a second function called insert. So this lets you, instead of adding it to the end, like append does, it can, as the name implies, insert something in there. So if I wanted to insert a new string, so let's say I wanted it to say hello world inside of the list, I would put world, and actually first would be the index. So the index in this case would be 3. So we're just going to pass in that 3, and then we'll print out list. And as you can see, in the 0, 1, 2, 3 position, you have world. And if you notice to the right of it, everything got shifted over by 1. So we didn't overwrite the 4 like we did with the, we didn't overwrite the 4 like we did with just changing that element. We added a new one. And moving on to removing functions, you can remove by the element as well. So the first way we can do this is by the position. So basically remove something at this position. The same thing with insert, except you don't really need to tell it what to delete. It'll just delete whatever's at that address. So if I said list remove 0, then it would delete that 1 at the very beginning. Oh, sorry. It would be list pop. My fault. Yeah, so it would be list pop 0, and that would and that would delete the first item. And could we have a print statement at the end of that, Sahas, really quickly? Yeah, thank you. Very easy to forget those things. And we print that out, and we're missing the 1. And the second thing we can do is we can remove it. So we can tell Python to look for this element and remove the first thing that you see of that element. So if I wanted to remove if I wanted to remove the word hello, I would just pass in the string hello into it. And while Sahas is typing that, we have a question. 3 is the rank. So yeah, 3 is going to be the location that you're inserting into. So basically, you're going to put something in there, and then everything from 3 and on will be shifted over by 1. All right, and here you can see that we have removed world. Okay, let's have a few seconds just to have any more questions before we move on. We do have 2 more data structures to go over today, so we will be moving a little bit faster. The difference between pop and remove. So pop lets you delete something by where it is. So basically delete the 5th element or delete the 1st element. Whereas remove is saying, okay, I want you to look for this thing and delete the first one that I find. Okay. I hope that answers your question. Moving on, there's a second data structure that's really important called a dictionary. So dictionaries are kind of similar to lists in that they hold multiple things, but they are a little bit different to use, and they are very efficient in terms of searching up values. So we'll get into that right now. So for anyone who's in computer science, I think it's 10C, it actually uses something called a hash table to basically look at things more efficiently and not have to look around, and it knows exactly where to find things. That information isn't really useful for coding in Python, but that's kind of like why dictionaries are more efficient. So how you start off a dictionary is just with curly brackets instead of square brackets. So it's in the same keys as the square brackets, you just hold shift instead. And one thing with dictionaries is instead of indexing by numbers like we did with lists, 0, 1, 2, 3, 4, 5, we're actually indexing by something called keys. So keys can be numbers, or they can be strings, basically anything, and you can have them set to a partner with the data. So think of keys as labels, and then the thing after this colon here is the item. So so here we have key 1 pertains to the number 10, right? And in that dictionary, if I printed out the dictionary by itself, it would print out exactly that, right? And in order to, let's say I wanted to get the value that has the label of key 1, I would, just like with lists, I would use square brackets, and then I would put in the key. So key 1, and then I would print that out. And as you can see, there's 10. And the cool thing is, you can actually have different types of different types of keys or labels. So you can actually use numbers as your keys. So let's say our key was 5, and we put the data of a string hello world. that pertains to it. Not the most practical use of dictionaries, but it is possible. So if we print it out, dict1, and then we use the key 5, notice how there's no quotes around it because it's an integer. And it actually gets hello world. Right. And one thing with dictionaries is that you cannot do it by address. So you can't do the thing with lists where you're indexing by where it is. You just have to index by the label. Think of it as there's a robot in your basement that grabs exactly what you want, but you don't know exactly where your boxes are. You just trust that the robot can get there way faster than you can. Okay. And yeah, so that's most of the main stuff about dictionaries. There's one thing that you can actually do with dictionaries is that you can create a dictionary from 2 arrays. So let's say I had an array of people's names and an array of their favorite colors, right? So while Sahas is constructing that, notice how these are lists. So we just went over this. So we're using square brackets, and in this case, we're just using all strings. And let's pretend that we have blue, red, and purple as our favorite colors, respectively. And what we can do is we can set a new variable called dict2, and we're going to call what's called a constructor, basically a function that creates a dictionary for us. And we're using our parentheses there. And we're going to do something called zip. So zip kind of tells Python, okay, we're going to look at both of these lists at the same time, and we're going to look at each item one by one in the list. So Sahas and blue will be paired together, Scott and red will be paired together, and Stephen and purple will be paired together. So if we print that out, it'll have everything pertaining to each other as we intended. Right, so Sahas's favorite color is blue here. My favorite color is red, which is not true. And Stephen's will be said to be purple, right? Any questions on that? So that's basically all the really fundamental concepts in for dictionaries. So these are very powerful. They're a lot faster than a lot of the things that you can do. You know, if you have millions of information and you're trying to get the exact one, it'll be almost instant instead of looking through the entire thing. Now, moving on, we're going to be talking about strings. So we've already seen strings last week. Oh, sorry, we have a question from Yazan. Yeah, I'm not sure if I said your name right, but yeah, go ahead.
Yeah, you said it right. I was wondering, so when we have names and colors, so basically if we labeled every color for every name, right? So if we say print the color of that name, it will give us the color of that name, right? That's how it works?
Yeah.
Thank you.
Yeah, good question. Yeah, and if there's no other questions, we'll continue to go over strings. Awesome. So strings, we've already gone over them a little bit last week. You know, they're basically words or sentences, or basically or groups of characters, right? One important thing to note is that strings are actually a lot more complex and they have a lot more power than just holding a bunch of characters. One thing that you can do is you can kind of insert variables into strings. So for example, if we had someone's age and we wanted to print out their age, instead of what we could do before, which is like, you know, Sahas is okay. Sahas is, and then we can add the age, and we have to cast it to a string, right? Yeah. Years old, and remember we're casting to a string and not an integer. Awesome. And if we print that out, that works perfectly fine. Sahas is 20 years old. But one thing is that it's pretty unwieldy to type, and it is technically a little bit slower. So what we're going to learn right now is called format strings, or F strings for short. Right? And how you tell Python that a string is going to be an F string is you're going to go right before that first quote. So right before the first quote, you're going to put an F. So between the parentheses, oh, no. Nope. There you go. Right before the first quote, you're gonna tell Python, okay, I want the string to be an F string. So you just put that F right there. And wherever you want to insert your variable, you put curly brackets. So these curly brackets are just like the ones that we use for dictionaries, except these are for, well, F strings. So here, as you might guess, we can just put an age. And that's going to actually do the exact same thing, and it will look a lot better, and it will be a little bit faster too. Right? And notice how we don't have to cast it here. So with F strings, it's automatically casted to whatever type that we need. So in this case, with our original implementation, we casted age to be the string 20, but here we can just put in the integer 20, and it'll do everything for us. Right. And and one cool thing with strings is that a lot of their functionality is overlap with lists a lot. So just like how we can index lists with square brackets, we can index strings with square brackets. So we had name equals Scott. And we wanted to say, okay, let's look at the third letter of Scott. So we would do name and then square brackets. And again, we're going to do one less. So we're going to do 2. And we print that out. And theoretically, we should have the letter O. Yep. So yeah, and the same thing applies with if you want to get a slice of a name. So if I wanted to get caught, then I could just do name from 1 to 4. And it would print out caught, right? Because it starts out at the first one, it goes all the way to the 4th one, but it doesn't include the 4th. And remember, we're starting at 0 there. So 1 would actually be the letter C. Right? Any questions on that part so far? Awesome. And so let's move on to a couple of functions that are unique to strings. So if you've taken C++ classes, you know that you can pretty easily convert all of the letters in a string to capitals. You can actually do the same thing with strings. So you do name.upper. And so upper is a function, so we're going to be using parentheses. And if you do dot upper, again, the upper means that the dot, whatever's on the left of the dot is the variable, and whatever's to the right is what function you're using. As you can see, it prints out Scott in all capitals. And just as we have upper, we have lower. So if I wanted to make everything lowercase, I can just do name.lower. Print that out, and it'll print out all lowercase. One thing to note is just like with printing out string slices, we're actually not changing the string itself. So if we were to print out name right below, it would actually have the original string, right? So name.lower just makes a new string, and it tells you, okay, this is what it would be like if you had all lowercase. And it does not overwrite anything. Okay. One thing too is to swap the case. So here, this is a really common error. You accidentally have caps lock on. You can actually swap the cases, and it'll, well, as the name implies, swap all the cases of every letter. Okay. And yeah, that's about it for character cases. Moving on to some, I think they're a little bit cooler functions that have to do with strings. So the first one is reversing a string. So if I wanted to print out my name backwards for some reason or another, you would print out reversed parentheses name. So note how dot reverse is not the right thing here. Reverse is actually a regular function that runs on a lot of different things. So you can just put in whatever data structure you have there, and chances are it'll reverse it. So if you print that out, oh, yes, that's true. Okay, so it'll basically make a new object or a new container for the reversed object. So if we put square brackets around those, yeah, and we print that out, then we can actually print out the each letter in reverse. That is not right. Sorry about that. Sahas, could you try casting that to a string? Okay, small technical difficulty. Here's one thing with Python. There's so many different functions that it is pretty easy to forget how to use those exactly. So we can go over that at the end of class. But moving on for now, we have a function called strip. So if you have an input from a user, for example, if you had them entering their name, and they add a space by accident, or they put a space at the beginning by accident, right? And this is a really common user error, and it is pretty annoying to deal with, especially if you're checking for exact strings. So one thing that you can do is the strip. So you do dot strip. So you do name dot strip and parentheses again. And as you can see, there's no space at the left anymore. If you notice, it does not remove spaces from the middle, right? It only removes it from the edges. If you want to remove specific, characters, like let's say I wanted to remove the T's at the end of my name, right? So if we got rid of those spaces in line 66, and and we wanted to take out the T's for some reason, you just pass in the character T. So we do our quotes, it doesn't matter which one, and we make sure we have a capital T. And as you can see, it takes out the T's from the end. And you can actually take it out from the beginning and the end at the same time. So if we added a bunch of capital T's to the left side, it'll actually print that as well. Right, so it'll take it out and it'll remove it from both sides. If you want to remove it only from one side, you can quickly just do R strip or L strip if you want to remove it from the right or the left, respectively. So we did R strip. It would show the T's at the beginning, but not the end. Okay. Any questions on that? Cool. So moving on, we can search for specific characters in the string. So let's have a new string called let's get a new string called hello, or just text, and we'll fill it with hello world. And let's say we wanted to find the first instance that we see the letter W, right? So what we can do is we print out text dot find. So that, again, that means the find function is pertaining to the string text. And we're going to pass in, just like with strip, we're going to pass in the character that we want to look for. All right, so we looked for W, it'll print out the location of where that W is. All right, so we have 0, 1, 2, 3, 4, 5, 6, and 6 is going to have W. And one thing to note is that, for example, if you were looking for a character that isn't inside of the string, let's say we try to find the letter Z, it'll return -1. So that's just kind of a convention with these kind of things. It's saying that, okay, well, there's not really any better number to put. You just put -1 so you know, okay, something's wrong. And we have a question: space is considered as a character? Yes, it is. So yeah, that's really important to notice that even if you don't see anything, that space does have a spot and it does take up a section of the string. Yeah, good question. Moving on, you have replace. So so if you wanted to replace let's say hello with hi, for example, you want it to be a little bit less formal. You do text dot replace. Again, replace is your function. And the first thing we're going to pass in, so you're going to have two things that you pass in. The first thing is what you want to replace. So you put in hello. And the second thing we pass in is hi. And we print that out. And as you can see, we replace the word hello with hi. So what it does is it looks for the place where hello is, and then it says, okay, whatever's there, I want to change it to hi, right? And let's print out text right after that to see if it changed anything at all. And always remember to save your files, folks. It's really easy to forget that. And as you can see, just like with the other functions before, this does not change the original string. So it's really important to pay attention to if you want to change it or not. You have to pay attention. And one last thing that we're going to go over with strings is that we can join different strings together, right? So let's say we wanted to do hello dash world, and this is a fairly small example, just for educational purposes. You could do this with a lot more, but what you can do is we type in whatever character we want to kind of link those two texts together with. So right now, if we want to do hello dash world, that dash is linking the hello and the world together. And now you're going to do a dot. So we're going to join it, and we're going to join strings based on the hyphen. So join takes in a list, and again, the list you use square brackets, and you just make a list with whatever you want in here. And one thing that we didn't mention with lists is that you can actually fill lists with variables. So here we're putting in the variables into our list, and we're not really setting it to a new variable. We're just leaving it there for join, right? We're not storing it or anything. And once we print that out, we have hello dash world, right? So if you had like a bunch of different, if you had a list that had, like 100 elements, then it would put a dash between all of them really easily. And this is a really powerful function, especially if you want to just format things really nicely. It's very convenient. One of the hallmarks of Python, a lot of the things that that take a lot of work in C++ are really convenient in Python. All right. Now we have about 10 minutes left, but are there any more questions about strings, or we're actually finished with our main content for today. So any questions on strings, dictionaries, or lists? Yeah, so going over one last thing before we move on to the homework. Earlier we looked at reversed, and that didn't go too well. So what you can do is, so let's say we had name equals Scott, for example. And reversed actually, reading it out, it returns a generator, or basically a really compact list of whatever is inside of the string. So here we have reversed Scott, or reversed name. So that'll turn it into something reversed, and then the list will convert it into a list. Right, so you have all the individual letters printed backwards. And if you wanted it to be a really nice string again, you could either print it out letter by letter, or you can typecast that list into a string. So on line 82, or we could just do new name, or our name equals, and how do we cast again? We do string parentheses temp, right? And we print out our name now. Oh, interesting. Well, looks like I've learned something new today as well. So that actually doesn't work exactly how I expected it to, but you could just print out each letter, and remember to set the end to be empty, and that'll print out the string by itself. Or won't? Huh, that's actually kind of weird. Oh, there you go. Yeah, so you run that on a list, and basically for every letter in the list, here's a quick demonstration on how you can loop through lists. You can actually just print out every single element in the list without anything behind it. Quick question on the upper function. Can you change the case on a specific character in the word? That's a good question. Off the top of my head, I don't think you can. Let's see. Sahas, do you know? I can do a quick Google search.
I haven't personally checked it out, but I do know that there was another function that we can kind of cover, which is capitalize. I'll just capitalize the first letter. But obviously that's not as good as being able to like capitalize or uppercase or lowercase specific letters.
Yeah.
If you ever want to take a look at how functions work, you can maybe hover over the text in VS Code, and it'll give you a little blurb about it. Returns a capitalized version of the string. Take a look at lower if it takes anything else in. No, it doesn't look like it. Or alternatively, what we can do, dot, and then we can kind of look through this.
Yeah, this is a really deep rabbit hole, which it is kind of easy to get lost in, but it is very powerful in the sense that you can see pretty much everything that you can do with a string.
I'm not finding anything.
Yeah.
You can check if things are lowercase or uppercase, though, it looks like.
Mm-hmm. Yeah, you don't get those pop-ups. That might be an extension you might have to install. Yeah, why don't you? Yeah, if you want, you can come to office hours. We can try to work that out. Off the top of my head, I think it should be built into your Python extension on VS Code.
Yeah.
Yeah, but yeah, again, come to office hours if you want. We can try to get that worked out. And with the last few minutes of class, we're gonna be doing a quick homework. It's a little bit easier than last week, and it's gonna be mostly on strings. So we're gonna be using we're gonna be doing something called Mad Libs. You know, it's that kids game where you have a story and you have fill in the blanks, and before you look at the story, you just fill in whatever you want. And this is a really good exercise in strings. So, let's say you had a really quick story. Once upon a time, there was a adjective noun who lived in a city, right? And here for our sake, in terms of coding as programmers, we want to be able to know that we want to replace those parts of the string. So basically, whatever is in a square bracket is a certain type of blank space. Okay, and and basically we're going to go through the entire string, and we're going to look for those square brackets and replace whatever string that we want with the correct type of blank. Right, and then you can have it ask the user to put in an adjective or put in a noun, right? So you would use like user input, for example. So Sahas, if you could just as a reminder, you can just do user input equals input, and then you know, you can tell them find or type in an adjective, right? And here you won't need to write an adjective exactly, right? It would be whatever you find within that blank. So between those square brackets, you don't want to just pop into that string, right? So there's multiple ways to do that. You learned about F strings earlier. Oh, what's wrong with that? You learned about F strings earlier. You could use those, or you can use replace. It's completely up to you. Yeah, and there isn't too much of a strict directions on this. It's mostly, okay, make sure that it works the same as us in terms of looking for those square brackets and replacing everything in there by asking the user, and then print it out. And this one is a little bit more open-ended. We welcome you to write whatever story you want. You can make it wacky. You can just make it really simple if you want. It doesn't, the length doesn't matter too much. Just try to have like at least 4 or 5 different blanks that you can replace. And yeah, I think that's it for the for this week's homework assignment. And make sure that you print out the entire story at the very end as well. Okay, any questions on that? Okay, and during our last minute of class, I'd like to remind everyone that we will have forms open for this homework, and just like with the last homework, we will be giving feedback. So the feedback for this past homework from day 1 will be coming out by, I think, Sunday night, right, Sahas?
Yeah, I believe so.
Yeah, so we'll be I think, emailing you with feedback that we have depending on your code, any problems or anything that you did really well that we are impressed with, anything that you could add on to it to make it even better. And then this will happen every time we do a homework assignment. So feel free to just when you submit it, we'll be able to give feedback on it, and hopefully that'll help you learn Python a little bit more. Any questions on that part? Anything in general, you know, homework, any of the content that we went over, how to submit. All right, if there's no further questions, I think we can go ahead and end the class for today. I can stop the recording.